Children, now today we are going to learn about a new topic, rational numbers. So before you have learned some number systems. So what are those number systems? Those are natural numbers, whole numbers, integers. So these are the three number systems which you learned in your earlier classes. So natural numbers are all counting numbers. They start from 1 to infinity. Next, it's denoted with capital N. Now coming to the whole numbers, all the counting numbers including 0 is called as a whole numbers. So it is denoted with W. Coming to integers, all the whole numbers and their opposites together form integers, and this is denoted with I or Z. Now today we are going to learn about a new number in the number system, that is rational numbers. So what is a rational number? A number which is in the form of P by Q. A number which is in the form of P by Q where Q not equal to 0. Where Q not equal to 0. Such numbers are called as rational numbers. You can write it as P by Q or A by B. Whatever will be the denominator is not equal to 0. So the numbers which are in the form of P by Q where Q not equal to 0 are called rational numbers. And these rational numbers are denoted with Q. These rational numbers are denoted with Q. Now we will see the properties of rational numbers. See, already we learnt the properties in whole numbers as well as in integers also. Now we will see one glance of it and we will go to our rational numbers. So first is a closure property. First is closure property. I am doing with first addition. All operations I am doing simultaneously here. First addition. This I am writing for first whole numbers. Whole numbers I am checking closure property for all operations. Addition, subtraction, multiplication and division. So actually what is closure property? When you add two numbers, then the resultant should also be a rational number. So for example, if I add 3 plus 2, 3 and 2 are rational numbers. So the result is 5, which is a whole number. Now in subtraction, 3 minus 2, it is 1, which is a whole number. But when you write 2 minus 3, it is minus 1, which is not belong to whole number. So subtraction is not closed under whole numbers. Now in multiplication, 3 into 2 is 6, or 2 into 3 is also 6. So 6 is also a whole number. So multiplication also satisfies under whole number. Coming to division, 3 divided by 2, that is, it is 1.5, which is not belongs to a whole number. So division also not satisfies here in the whole number part. Here in addition of whole numbers, see, closure property, addition and multiplication satisfies, but whereas subtraction and division are not satisfied. Now we will see this closure property in integers now. So Here also I am checking all the 4 operations: addition, subtraction, multiplication and division. If I take 3 minus 2, the result is 1, which is an integer. So addition satisfies in integers. 2 minus 3, it is minus 1, which is also belongs to an integer. So subtraction also holds good in integers. Multiplication, 2 into minus 5, it is minus 10, which belongs to integer. So multiplication also holds good in closure property. Now, whereas here division, 3 by minus 2, your answer is minus 1.5, which is not an integer. So division won't satisfy here in the closure property of integers. So integers, closure property, addition, subtraction and multiplication satisfies, whereas the division is not satisfied, closure property in integers. Now we will see the same property, rational number properties, closure property on rational numbers now. Here also I am checking all the 4 operations at a time. If we take addition, so if I write 1 by 2 plus 1 by 4, these two are rational numbers. So if I simplify this, the LCM of 2 and 4 is 4. So 2 2, so 2 plus 1, it is 3 by 4, which is a rational number. So the addition of rational numbers is closed. So now subtraction. If I write 1 by 4 minus 1 by 2. So here also the LCM is 4. So we have 1 minus 2 2's. So 2, it is minus 1 by 4, which is also a rational number. So that also becomes, the subtraction also holds good in closure property of rational numbers. Now coming to multiplication, 1 by 4 into 1 by 2. So it is 1 by 8. It also belongs to a rational number. So this also, multiplication is also closed under rational numbers. Coming to your division. For example, 1 by 4 divided by 1 by 6. If I write like this, then 1 by 4 into 6. 2 2's, 2 3's. So 3 by 2, which belongs to a rational number. But it won't satisfy in all the cases of division. In all the cases of division. So for example, a divided by 0 means 1 by 4 divided by 0 if I do. The answer is 0. But if I divide 0 with a rational number, then it is undefined. So you can't say that division satisfies closure property. In all cases, it won't satisfy. So here also you will say that in the closure property of rational numbers, addition, subtraction, multiplication satisfies, but whereas division won't satisfy. Now we will check the second property, that is commutative property. Again we will check with the whole numbers and then integers, and then we will come to rational numbers. Now with the whole numbers, commutative property. What is commutative property? If you change the order of the numbers also, the resultant should be same. So here, if I take 5 plus 2 equal to 2 plus 5, it is equal to 7. So a plus b equal to b plus a. So here the in addition, commutative property satisfies. Now coming to your subtraction. 8 minus 10 is not equal to 10 minus 8. 8 minus 10 value is minus 2, and here the value it is 2. So which is not equal. So in subtraction, commutative property won't satisfies. It's not holds good in commutative property. Now coming to your multiplication. 5 into 2 is equal to 2 into 5 equal to 10. So here also when you multiply 5 into 2 it is 10, 2 into 5 it is also 10. Even though you interchange the order of the numbers, commutative property satisfies in multiplication. Now coming to your division. 5 divided by 2 is not equal to 2 divided by 5. So division won't satisfy commutative property in whole numbers. So here in whole numbers the commutative property satisfies only for addition and multiplication, whereas subtraction and division it won't satisfy. Now we will see commutative property in integers. I am doing here for all the operations. So now for addition. 4 minus 5 if I do, and minus 5 plus 4 if I write like this. So what is your answer? 4 minus 5 is minus 1, minus 5 minus 4 plus 4 is minus 1. So in integers addition of commutative property holds good. Now coming to your subtraction. See, 8 minus 5 is equal to 5 minus 8. 8 minus 5 answer is 3 and is not equal to minus 3. So closure in commutative property, integer subtraction won't satisfy. Coming to your multiplication. 4 into minus 2 is equal to minus 2 into 4. The value is equal to minus 8. So multiplication also holds good in commutative property of integers. Coming to your division. 4 divided by minus 2 is not equal to minus 2 divided by 4. So here division also not satisfies in commutative property. So in integers here only addition and multiplication holds good as in the commutative property of integers, but subtraction and division does not holds good. Now we will see on rational numbers what's about the commutative property. Here also addition satisfies. So 1 by 2 plus 1 by 4, it is 1 by 4 plus 1 by 2. If you do, the results are same. So addition satisfies in commutative property. Now coming to subtraction. 1 by 2 minus 1 by 4 is not equal to 1 by 4 minus 1 by 2. So commutative property won't satisfy in rational numbers. Now coming to multiplication. 1 by 2 into 1 by 4 is equal to 1 by 4 into 1 by 2. So here multiplication is commutative on rational numbers. Coming to your division. 1 by 2 divided by 1 by 4 is not equal to 1 by 4 divided by 1 by 2. So division is also not satisfied for commutative property of rational numbers. So in rational numbers addition and multiplication satisfies, but whereas subtraction and division won't satisfy for the commutative property. Now we will see the next property, associative property. First for the whole numbers. So what is associative property? If you change the grouping, A plus B plus C is equal to A plus B plus C. So here associative property satisfies in whole numbers of addition. Now coming to subtraction. A minus B minus C is equal to A minus B minus C. Even though you change the order here, it is not equal. So subtraction won't satisfy in associative property. Coming to your multiplication. A into B into C should equal to A into B into C. They both are equal. So multiplication satisfies associative property of whole numbers. Now coming to your division. A divided by B divided by C is not equal to A divided by B divided by C. So division won't satisfy associative property of whole numbers. So here associative property only in addition and multiplication it satisfies, whereas subtraction and division won't satisfy associative property of whole numbers. Now we will see associative property in integers. It is also same as addition of whole numbers. So addition of whole numbers is A plus B plus C is equal to A plus B plus C. That is also satisfies in integers. Coming to your subtraction, A minus B minus C is not equal to A minus B minus C. So subtraction only holds good in integers of associative property. Now coming to multiplication, it is also same. A into B into C is equal to A into B into C. So here also multiplication property satisfies. Coming to your division, A divided by B divided by C is not equal to A divided by B divided by C. So in integers also only addition and multiplication satisfies, whereas subtraction and division won't satisfies. Now we will see associative property in rational numbers. It is also same like here whole numbers and integers. In the same manner, in addition, A plus B plus C is equal to A plus B plus C. So addition satisfies associative property of rational numbers. Whereas coming to your subtraction, A minus B minus C is not equal to A minus B minus C. So subtraction won't satisfy the associative property of rational numbers. Coming to your multiplication, A into B into C is equal to A into B into C. So here also multiplication satisfies the associative property of rational numbers. Now coming to your division, A divided by B divided by C is not equal to A divided by B divided by C. So division won't satisfy for associative property of rational numbers.